we want to look at the equations that can form these lines. When you look at a linear equation, the solutions can be represented by a graph. And that is, we're looking at a linear equation in two variables. For example, if we have x plus y is equal to 5. There are a lot of solutions to this equation. We could have a table to show some of the solutions. Like we know that if x is 1, then y would have to be 4. If 4 was x, then y would have to be 1. Or we could say x is 2 and y is 3, or x is 0 and y is 5. All those things satisfy that equation, and there's an infinite number more. We could start talking about fractions. We could say, oh, well, 2.5 could be x, and 2.5 could be y, and so on. Now, to represent those infinite solutions, I can look at a graph. And to do that, I plot those points. I have 1, 2, 3, 4. I have the point 4, 1, 2, 3. If you're not seeing these labels here, I could label this for you. And we also have 0, 5. So these dots that I'm drawing, I'm actually plotting each of these points. These are ordered pairs. And they're telling me what my x value is and what my y value is, because all our ordered pairs are the form x, y. Now if I connect these dots together, this line is formed. And it goes forever in both directions. I'm putting these arrows on here. But every single dot that makes up this line is a solution to this equation. It has to satisfy that equation. Now, one important characteristic of a line is the slope. When we talk about the slope, this is our steepness of the line. So the larger the slope we have, the steeper that it is. Another way we can think about our steepness is how fast the line is going vertically to how fast the line is going horizontally. Some people denote it as the rise, that's our vertical movement, over our run. And our notation for slope, we write the letter m. So if we look back at our above graph, if we pick one point, let's look at this point, the coordinates are 4, 1, and let's actually go all the way to this point, which is 0, 5. I can look at how many steps up I have to take to be at that height. So that's my vertical movement. 1, 2, 3, 4 spaces up. And then I need to see how many spaces to get to that point horizontally. There's 2, 3, 4. Since I moved to the left, I'm going to put that 4 as a negative. So in other words, for this example, I would say that my slope is equal to the rise over run, which is going to be 4 over negative 4, which is negative 1. Now, a slope is a ratio really between the rise over run between any of the points on our graph. So if I go up 1 and left 1, that should still put me on my graph. I go up 1 and left 1, it still puts me on my graph. Now, in general, we can write an equation that can help us find the slope. So if I look at a graph and I pick any 2 points on it, let's find one point here. I'm just going to label this as x1, y1. And I'll pick another point and say here, and I'm going to call that x2, y2. The little subscript is just saying that's the second point I picked out, and the little ones are just saying that's the first point that I picked out. Now, if I want to see the slope between these two lines, I want to see how much I have to go up and how much I have to go over. That's my rise over run. Well, if I'm talking about this vertical distance here, I know that I am at y1, and this top point I know is at y2. So if I want to find this distance, I will subtract them. y2 minus y1. Now, when I go left to right, this point right here is at x1. This point is at x2. So again, to find the distance between them, I will subtract x2 minus x1. And that will get me the slope between those 2 points. And in general, between any 2 points. So we could check this with what we did earlier. We were looking at our points were 4, 1, and 0, 5. So to find our slope, we could take our y's and subtract them to find the distance between them, take our x's and subtract them to find that distance, and we end up with 4 over negative 4, which is negative 1. Now, if you're given a slope and a point, we can write an equation. So we can call our slope our m, and we're talking about a specific point, x1, y1. Now, in general, what we're talking about is that we have a particular point, x1, y1, and then we can talk about the slope between that and any other point that happens to fall on our line. So I'll label that one just xy. Now, we know that if we want to find the slope between these 2 points, that m is equal to y minus y1 over x minus x1. So this is a little different than the actual just slope formula, which took 2 specific points, because this is in general. So now if we try and manipulate this a little bit, we can multiply by x minus x1 on both sides, which leaves us with x minus x1 times m is equal to y minus y1, since those reduce. Or if we flip that around, we'll have y minus y1 equals m times x minus x1, which is the point slope form of an equation. Now, in particular, we could look at that specific point, x1, y1, as being the y-intercept. So let's imagine that we have a y-intercept, and we'll label this 0, b, where b is the y-coordinate of our y-intercept. And we're going to look at that point in relation to some other point that's on the graph, just some point in general. Again, we'll say that the slope between the y-intercept and any other point is m. So we could write m is equal to y minus b over x minus 0. Well, that's just m is equal to y minus b over x. If we multiply both sides by x, we get mx is equal to y minus b. If we add b to both sides, we get mx plus b is equal to y, which we can write y is equal to mx plus b, which is our slope-intercept form of an equation.